Welcome to Study Loop.
So first we will take segment from A to C. In the segment from A to C, pressure is constant, so we can calculate work done by using the relation work done equal to pressure times change in volume, which is equal to pressure. Here change in volume is volume at point C minus volume at point A. Here pressure is up to point A. There are 6 squares on pressure axis, and each square shows 2 times 10 to the power 4 Pascal. So pressure of point A as well as pressure of point C will be equal to 6 times 2 times 10 to the power 4 Pascal into volume of point C. Here on volume axis, side length of each square is 2 times 10 to the power minus 3 cubic meter, and there are 1, 2, 3, 4, 5 squares. So this gives us volume of point C equal to 5 times 2 times 10 to the power minus 3 cubic meter minus volume of point A is up to point A. There are there are 13 squares on volume axis. So volume of point A will be 13 times 2 times 10 to the power minus 3 cubic meter. So this gives us pressure equal to 12.10 to the power 4 Pascal into volume of point C is 10 times 10 to the power minus 3 cubic meter minus volume of point A is 26 times 10 to the power minus 3 cubic meter. So this gives us work done in the segment A to C equal to minus 1920 joule. Now by using first law of thermodynamics for the segment AC, we can write Q in the segment A to C equal to work done from A to C plus change in internal energy from A to C. This gives us work done from A to C, which we have already calculated, that is equal to minus 1920 joule plus change in internal energy from A to C is internal energy at point C minus internal energy at point A. So this is the heat in the segment A to C. Now we want to take segment from C to B. In this segment, volume is constant, so change in volume is equal to 0. So this gives us work done from C to B also equal to 0. Now again, by using first law of thermodynamics, we can write Q from C to B equal to work done from C to B plus change in internal energy from C to B, as work done from C to B equal to 0. So this gives us heat from C to B equal to change in internal energy from C to B. So here change in internal energy is internal energy at point B minus internal energy at point C. Now we can easily calculate net heat for the process ACB. So for the process ACB, net heat is equal to heat released or absorbed in the segment A to C plus heat released or absorbed in the segment C to B. As in the segment A to C, heat released or absorbed is minus 1920 joule plus internal energy at point C minus internal energy at point A, and Q from C to B is internal energy at point B minus internal energy at point C. So here internal energy at point C, that is in positive, and internal energy at point C, that is in negative. So these both will be cancelled. So this gives us net heat equal to minus 1920 joule plus internal energy at point B minus internal energy at point A. So that is equal to Q equal to minus 1920 joule plus change in internal energy from A to B. So here UB minus UA, that is change in internal energy in the segment A to B, as it is given in the problem that segment AB is an isotherm. So in isotherm, temperature is constant. So this gives us change in internal energy from A to B equal to 0. So by plugging the value of change in internal energy equal to 0 here, Q equal to minus 1920 joule plus change in internal energy in isotherm is 0. So this gives us Q equal to minus 1920 joule. So here the net heat is negative. This shows that heat flows out of the gas, out of the gas. That's the end of the problem. Thanks for watching.